Kia ora. So this is the fourth video in my series showing my worked solution for Achievement Standard 2.14, the Practice Assessment Performing Arts Showcase. So in this video, I'm going to go through the solution to task 1 and also the solution for 2012. So what we've worked out is that the change in the adult ticket sales in 2011 compared to 2010 must be, so in 2011, so that's the later year, 105 adult ticket sales, whereas in 2010 we had 250. So the change in those numbers is a decrease of 145 adult tickets. So fewer tickets were sold that year. So what I'm going to do now is we'll go on to 2012. So what we're told for 2012 is the cost of a child ticket is planning to be $5 and the cost of an adult ticket is not determined yet. The way that we can write that down as an equation is if we let, and I'm just choosing a letter capital A for adult ticket. So if we let that equal the adult ticket cost, which is in dollars, then we can form the equation. So 5x plus AY equals $3,210. So this is the total amount of profit we will make. And we'll call that equation 1. We're given equation 2, which is 200x plus y squared equals 80,000. And we're also told a critical bit of information, which is that there needs to be only one possibility for the number of child and adult tickets to be sold. So going back to our understanding of the discriminant of a quadratic, the discriminant then, b squared minus 4ac, so the part under the square root in the quadratic, must equal 0. And we'll call that equation 3. All right, so we're going to follow the same process to be able to solve these, whereby we are going to look to rearrange equation 1, and I think I'll clear the board a little bit, I think, for us to be able to do that. Now I'm just going to proceed forward with that right side of the board, just looking at my space allocation. So what we're going to do with equation 1 is rearrange this and solve this for x. So if we move the ay from the left-hand side to the right, it will become negative ay. So then we'll have 5x equals 3,210 minus ay. Then we need to divide through by 5. And when we do that, 3,210 divided by 5 is 642, and then we'll have negative ay over 5. Okay, so that's our equation, which we'll call equation 1 star. And like we've done with the others, then what we'll do is we'll look to substitute equation 1 star into equation 2. So instead of writing x here, I'm going to write 642 minus ay over 5 in brackets plus y squared equals 80,000. So the next part we'll look to do is to expand out the brackets. So 200 times by 642, we're going to get 128,400 minus, and then we've got 200, so it's going to be negative 200 divided by 5, so that'll give us 40 ay plus y squared equals 80,000. Okay, so just like the others, we'll just want to rearrange that, setting it equal to 0 and simplifying. So we've got y squared minus 40 ay. Then you've got your plus 128,400 minus 80,000 because we'll move that across to the other side, and that'll give us positive 48,400 equals 0. Looking at the coefficients here, so A is 1, B is negative 40A, and C positive 48,400. So now we'll look to clear the board. So from equation 3, we've got b squared minus 4ac equals 0 because of the one solution criteria. So I'll just write here from equation 3, so b squared minus 4ac, so we've got b here as negative 40a, so negative 40a all squared minus 4 times by a times by c equals 0. Okay, so if we expand out the brackets there, that's going to give us 1600a squared minus 193,600 equals 0. So we're looking to solve for a, obviously, so that means we can move the 193,600 across. Hopefully you're okay with me also then dividing through by 1600. So that's a squared, and if we solve that, it's 121. So a then is the square root of 121, and you're going to get two solutions there, one's positive and one's negative. So either a equals $11 or a equals negative $11. Now obviously the negative $11 would be an invalid solution, because that would be crazy if you were actually paying someone $11 to come to the show. So therefore the correct solution is the adult ticket price is $11.